So if we have to differentiate between oxidation and reduction, that's just bookwork, and oxidation is the loss of electrons, whilst reduction is the gaining of electrons. Electrons are transferred. That's also a pretty good thing to put in when you're differentiating, because both of them involve the transfer of electrons, but oxidation is the loss of electrons and reduction is the gaining of electrons. Identify the oxidizing agent and reducing agent in the reaction below using oxidation numbers, which means I'm going to mark your oxidation numbers. Anything on its own is 0. Aluminium's in group 3, so it's +3. Chloride is in group 7, so it's -1. It does turn out to be 0 because there's 3 -1s and 1 + 3 over there. And then you're going to identify that your oxidation is over there and your reduction is over there, which means that chlorine is a oxidizing agent and the aluminium is the reducing agent. What type of bonding takes place in aluminium chloride? Aluminium is a metal, chlorine is a non-metal, so it is going to be ionic bonding because it is between a metal and a non-metal. You could have gone into electronegativity difference, but it wasn't necessary. Going back to 8.2, 8.2 is your rice table. It doesn't get asked like a rice table. I mean, they ask all sorts of other questions. If I were you, though, when I got this information, I would first do a rice table and then attempt to answer the questions that they've asked me. First thing to do is to say, I want Kc. Kc is the concentration of the products over the concentration of the reactants raised to the power of the coefficient in front of them, and then leave it like that. Now go into the actual rice table. You had your balanced equation. It was 2SO2 plus O2 gives you 2SO3. So the ratio is given already, 2:1:2. Initially, I have got 0,25 moles of sulfur dioxide and 0,2 moles of oxygen. That's given to me. They are placed in, remember, at the end of this with V and concentration, and so the volume is going to be a 2 decimeter cubed container all the way across. That's in, and it's sealed. Equilibrium is reached after a certain time, and it is found that there are 0,2 moles of SO3. So at equilibrium, I have got 0,2 moles. I don't start with any SO3. I don't consume any SO3. I now link the consumed of the reactants with the equilibrium of the products, and I say 0,2 is to 0,2 is going to be to 0,1. So it's 0,1 over there and 0,2. So I started with 0,25. I used 0,2. I'm left with 0,05. Over here, I started with 0,2. I used 0,1. I'm left with 0,1. Now I've got to work out all these concentrations. I simply take number of moles, because remember, this is number of moles, this is number of moles, this is number of moles. I take the number of moles and divide it by the concentrate, at least the volume, 0,025, 0,05, 0,1. Substitute those values into the equation that I have already written, and I have got 0,1 squared divided by 0,025 squared and 0,05, and I get 320. That is calculate the value of the equilibrium constant, so I've done that. Just need to label it, and I can say that that is 8.2.3. And then there were some questions a little further back over there, which was determine the number of moles of SO2 at equilibrium. So if I want the number of moles of SO2 at equilibrium, I land up with 0,05 moles. And I now neatly just next to this go 0,05 moles. And calculate the concentration of sulfur dioxide and oxygen at equilibrium. So those are these two answers over here. And I simply write them down next to this 0,025 moles per cubic decimeter. And that's your SO2 concentration. And your O2 concentration is going to be 0,05 moles per cubic decimeter. And that's how you can work those in. But you've done your rice table conventionally and how you have trained yourself to do it properly.